In the skies over Germany in 1941, death wasn't personal. For an RAF bomber crew, it was a mathematical certainty. German anti-aircraft fire, the dreaded Flak, didn't need a direct hit to kill you. Every shell that burst within 70 yards of your plane filled the air with thousands of steel fragments, each travelling faster than a rifle bullet. The Luftwaffe had turned the sky into a brutal probability equation, and the house always won. By August 1940, Bomber Command was learning this lesson in blood. Germany had nearly 2,000 heavy flak guns pointed at the sky, dominated by the legendary 88mm. These weren't crude relics. They were precision weapons linked to mechanical computers that calculated your speed, your altitude, and the time it would take for their shell to find you. A skilled crew could put 20 rounds a minute into a pre-calculated box of sky. They didn't aim at individual planes. They created kill zones. The statistics were horrifying. During a daylight raid on Cologne in August 1941, Flak accounted for nearly 70% of all bombers lost. A Lancaster was a massive target, nearly 70 feet long, with a 102-foot wingspan, crawling through enemy airspace at just 200 miles per hour. During the bomb run, flying straight and level, a German gun crew had 30 seconds to lock on and fire. In aerial combat, 30 seconds is an eternity. And the math got worse. German doctrine favoured barrage fire multiple batteries, creating overlapping three-dimensional boxes of explosions that bombers had to fly through. The Ruhr Valley, Germany's industrial heartland, was protected by over 1,000 heavy guns. The sky literally became a minefield, invisible until the fragments were already tearing through metal and flesh. When Air Marshal Arthur Harris took over Bomber Command in early 1942, he faced an impossible situation. The Wellington, Stirling, and Halifax bombers simply couldn't survive in daylight. A disastrous raid on Augsburg in April proved it. Of the 12 Lancasters sent, 7 were shot down, and 3 more were so badly damaged they were written off. A 60% casualty rate in a single afternoon. The only answer was to fly at night. But this came at a huge cost. Night bombing meant sacrificing accuracy for survival. Instead of hitting specific factories, bombs were scattered across entire districts. It was a strategic admission that Germany, with its engineering and mathematics, had won the daylight war. The equation had to change, and the man who would change it was already climbing into a strange wooden prototype at a quiet English airfield. The de Havilland Mosquito was about to prove that speed could beat statistics. On paper, it was a ridiculous idea. When Geoffrey de Havilland proposed it in 1938, the Air Ministry hated it. A bomber made of wood, plywood and balsa glued together like furniture. No one wanted it. Fighter Command wanted metal Spitfires. Bomber Command wanted four-engine giants. This wooden oddity seemed like a step backward. German intelligence agreed. When they saw reconnaissance photos, they laughed. They called it Der Holzbomber, the wooden bomber, or Der Möbelbomber, the furniture bomber. Germany was building advanced all-metal war machines. The British, it seemed, were reduced to gluing planes together in a workshop. The mockery grew when they learned its specifications. The Mosquito carried no defensive guns. Its bomb load was a fifth of a Lancaster's, and it used 2 precious Merlin engines that could have gone into fighters. To the Germans, it screamed desperation. A bomber made of trees. What they failed to grasp was the genius behind the design. Getting rid of guns and gunners saved nearly £2,000. The wooden construction wasn't a weakness, it was a strength. It was lighter than aluminum and incredibly resilient. Shells that would detonate inside a metal bomber often passed straight through the Mosquito. Wooden fuselage without exploding. But the real secret, the thing that broke the equation, was its speed. The prototype hit 390 miles per hour. The first production models entering service in late 1941 could cruise at 380. That made it faster than the Messerschmitt Bf 109, faster than the early Focke-Wulf 190. It was faster than anything German intelligence believed a bomber could be. The first encounters were baffling for Luftwaffe pilots. The bomber they were sent to intercept would just ... accelerate away. Even in a full power dive, a German fighter could barely close the distance. The moment they leveled out, the Mosquito was gone. The furniture bomber, the joke made of wood and glue, was untouchable. It was a phantom that defied the math, a ghost in the machine that Germany could not catch. The Mosquito wasn't just a plane, it was a revolution, and it was about to change the war. In the dark days of 1942, a radical new aircraft was becoming Germany's worst nightmare. It was called the de Havilland Mosquito, a plane made almost entirely of wood, and it was so fast it didn't need to fight its way through defences, it simply outran them. The furniture bomber, as some called it, could slip through flak belts faster than anything the Reich could scramble into the sky. But speed alone wasn't enough. Britain's Bomber Command, led by the notoriously sceptical Air Marshal Harris, demanded proof. He needed to know if this wooden wonder could survive where conventional bombers died at extreme low altitude, right in the heart of German flak. The challenge was thrown down. Prove that speed could defeat the guns that tore heavy bombers to pieces. The entire Mosquito program and the future of Britain's fast bomber strategy hung in the balance. The man chosen for this near-suicidal mission was Geoffrey de Havilland Jr. He wasn't just Britain's chief test pilot, he was the son of the company's founder. For him, this wasn't just a job, it was his family's legacy on the line. He had to fly a Mosquito at its absolute maximum speed, below 200 feet, directly over a British airfield packed with sceptical high-ranking officers. Their stopwatches and cameras would decide the plane's fate. If he succeeded, the Mosquito would go into full production. If he failed, the program would be scrapped. The physics were terrifying. German 88mm guns were deadly even down to 500 feet. British intelligence believed that under 200 feet, at over 350 miles per hour, a plane moved too fast for German gun predictors to get a lock. But this was just a theory. Jeffrey had to make it a reality. At that speed and altitude, the ground rushes up at you, covering over 100 yards every single second. There's no room for error, no time to react. A single mistake, a sudden gust of wind, and the plane would disintegrate. The wooden wings, while strong, were being pushed into uncharted territory. Throughout February 1942, Jeffrey practiced relentlessly over the English countryside. He flew lower and faster each time, learning the Mosquito's every quirk as the ground blurred beneath him. He studied German Flak doctrine, memorizing gun traverse speeds and calculating every variable. He wasn't just flying a plane, he was preparing for a deadly dance with physics and enemy firepower. Then came the day of the test, February 25, 1942. The sky over Hampshire was cold and clear. At RAF Farnborough, a delegation from Bomber Command gathered, their arms crossed, ready to shut the Mosquito down. 30 miles away, Jeffrey de Havilland Jr. climbed into the cockpit of Mosquito W4050. He was just 30 years old, carrying the weight of his father's company and Britain's hopes on his shoulders. He took off and headed south, pushing the engines to their limit. On the ground, the officers waited. They heard it before they saw it, a rising, tearing scream of two Merlin engines at full power. Suddenly, the Mosquito burst over the airfield boundary. It wasn't just low, it was practically mowing the grass. Observers swore it was flying below the height of the control tower. It was a blur of motion, a streak of wood and power moving at nearly 400 miles per hour. The Mosquito shot across the airfield in a matter of seconds and vanished. Then, to prove it wasn't a fluke, de Havilland circled around and did it again. The silence that followed was broken by the stunned murmurs of the officers. They had their proof. It was undeniable, photographed and timed. Speed really could be armor. That day, Jeffrey de Havilland Jr. didn't just save an aircraft program. He unleashed a weapon that would change the course of the air war. The wooden wonder had earned its place in history. Thanks for watching. If you enjoyed this story of courage and innovation, be sure to like this video and subscribe for more incredible tales from history. See you next time. Ever heard of the Mosquito, the British bomber so fast it could outrun almost anything thrown at it? Well, the Germans had a secret weapon they thought could stop it. The Flak predictor. This wasn't just a simple sight. It was a beast of a machine, an electromechanical computer the size of a desk, weighing over 550 pounds. It was a marvel of engineering, designed to bring down high-flying enemy bombers with deadly precision. So, how did this thing work? It was incredibly sophisticated for its time. Operators would feed it all sorts of data. The target's altitude, its direction, its speed, even wind conditions, and whether it was climbing or diving. The predictor would crunch all these numbers and then calculate the perfect moment to fire. where to aim, and even how to set the fuse on the shell so it would explode at the right altitude. It would then send all this information electrically to the massive 88mm anti-aircraft guns, which would automatically swivel and elevate to the exact right position. It was an ingenious, almost futuristic system for its day. But here's the catch. For all its genius, it was slow, really slow. Think about it like trying to solve a complex math problem while the answer keeps changing. To get a lock on a target, the process involved a series of precise steps, and each one ate up precious life-or-death seconds. First, the optical rangefinder's basically powerful, specialized binoculars had to spot the incoming bomber. Then, the operator had to hold the target perfectly steady in the crosshairs for at least 2 seconds. This was just to get an accurate measurement of how far away it was. Now, the best, most elite German gun crews, under perfect conditions with clear skies, and a target flying straight and steady could maybe shave this down to 1.5 seconds. But in the chaos of an air raid, that was a huge ask. After getting the range, the predictor needed even more time. The crew had to keep tracking the plane continuously for another 3 seconds. This constant stream of data allowed the computer to figure out the plane's speed and its exact flight path. So right there, you're already at 4 to 5 seconds, and the gun hasn't even aimed yet. Next, the predictor would spit out its firing solution. This data had to travel through electrical cables to the gun itself. Once the gun received the instructions, powerful servo motors would kick in, swinging the heavy barrel into position. Depending on how much the gun needed to move, this could take another 1 or 2 seconds. So let's add it all up. From the moment a target was first spotted to the instant the gun was actually ready to fire, it took a minimum of 5 to 7 seconds, and that was for the absolute best crews in the world. For an average crew, it was more like 8 to 10 seconds. And remember, all of this assumed the target was playing nice flying in a straight, predictable line. Any sudden jink or turn, and the whole process had to start over. Now, enter the de Havilland Mosquito. This plane wasn't your average bomber. It was known as the Wooden Wonder and was famous for its incredible speed and its ability to fly at treetop level. And this is where the Germans' ingenious system fell apart completely. Imagine a mosquito screaming towards you, not high in the sky, but just 20 feet off the ground, a blur of motion traveling at over 300 miles per hour. At that ridiculously low altitude, the mighty 88mm gun had a major problem. Its effective horizontal range was only about 1,200 yards. If the plane was any further away, the gun simply could undepress its barrel low enough to shoot at it without firing straight into the ground. So you have this tiny window of opportunity. 1,200 yards. Let's do the math. A mosquito traveling at 300 miles per hour covers that 1,200-yard distance in just 5.8 seconds. Think about that, 5.8 seconds. That's barely enough time for even the most elite, well-drilled German Flak crew to get a firing solution under perfect, ideal conditions. Against a fast, low-flying and erratically moving Mosquito, it was nearly impossible. By the time the predictor had figured out where the Mosquito was going, the plane was already gone, leaving the gun crews staring at an empty sky. The Mosquito simply outpaced the technology designed to destroy it, proving that sometimes speed is the ultimate armor. Thanks for watching, and if you enjoyed this dive into military history, make sure to hit that subscribe button for more. See you next time. Have you ever heard of a weapon so fast it literally outran the math meant to stop it? That was the de Havilland Mosquito, a British bomber that rewrote the rules of air combat for German anti-aircraft crews. It was a nightmare. A typical bomber would appear on the horizon, giving them time to track it, calculate its path, and open fire. But the Mosquito, it didn't appear. It erupted. It would burst into view already close, screaming in at treetop level. Crews often had less than 3 seconds before it was on top of them. The fire control computers, the pride of German engineering, were useless. By the time they calculated where the Mosquito had been, the plane was already gone, hundreds of yards away, leaving shells to explode in empty air. It was a ghost made of wood and powered by speed. Unlike heavy bombers that had to fly straight and level on their bombing runs, Mosquito pilots could jink and weave, using every tree, building and hill to stay hidden until the last possible second. Even filling the sky with a wall of flak didn't work. How can you build a wall when you don't know where the attacker is coming from? Physics had beaten engineering. Speed had defeated prediction. The head of Bomber Command, Air Marshal Harris, saw the potential immediately. No committees, no red tape. In late 1942, he greenlit a mission to prove the Mosquito's worth. The target, the Philips Electronics factory in Eindhoven, Holland. Deep in enemy territory, heavily defended and crucial to the German war machine. This was Operation Oyster. If the Mosquito could pull this off, it would prove it could strike with precision in broad daylight and get away with it, something no other bomber could do. The plan was audacious. Fly across the North Sea just 50 feet above the waves, cross into Holland at treetop height, and use roads and canals as a map. Speed was the only defense. They had to hit the coast at 330 miles per hour, accelerate to full throttle on the final approach, and be gone before the German Air Force even knew what was happening. The entire time over enemy territory would be about 12 minutes. On the morning of December 6, 1942, the weather was perfect. 14 Mosquitoes took off and streaked across the sea. German radar picked up faint blips, but the signals were weak and inconsistent. The planes were too low, too fast, and their wooden frames barely showed up on scopes. By the time Luftwaffe fighters were scrambled, it was already too late. At 12:30 p.m., the Mosquitoes reached Eindhoven. They popped up to just 400 feet, released their bombs, and banked away hard. The German flak guns opened up in a panic, firing wildly, but the bombers were already gone. They were firing at ghosts. The Phillips factory was left in ruins. The Mosquitoes had flown into the heart of the Reich, delivered a knockout blow, and vanished. Operation Oyster was a stunning success, and it cemented the Mosquito's legend as the Wooden Wonder, a bomber that was simply too fast to catch. Thanks for watching. If you enjoyed this piece of history, make sure to like and subscribe for more stories of incredible machines and the people who flew them. See you next time.